david7sanstheater@gmail.com. That's how you can contact us. And today I want us to teach you about the integrated response to stress. How does the body mechanisms respond to stress in times of stress? Okay, look at this. Don't forget to like, subscribe, and share. Yeah, share for more and better videos. Share to your friends. Yeah, subscribe for more and better videos. You like how things are always good. They are good. Okay, forms of stress. That's what I want to start with. Stress occurs to the body. Stress takes different forms. It can be emotional, it can be physical or biological. So biological stress occurs in times of surgery, occurs when the body is anesthetized. It occurs if you have infections, if you lose some blood, hemorrhage, if you're having hypoxia, low blood oxygen, and if you have low oxygen in the body tissues, and if you have low glucose, that's when you have biological stress. Now, the physical stress occurs in times of pain, exercise, exposure to extreme temperatures, that is causing physical stress. Emotional stress can occur in anxiety, anger, fear, or fatigue. All these three forms, biological, emotional, and physical pain, they cause stress signals to be sent to the limbic system. Limbic system, that one will include the hypothalamus and the like, amygdala and the like. So the cortex is also involved in receiving those signals. So is the reticular activating system of the reticular formation. We saw last time it sends collateral signals, the pain fibers, the stress signals. Okay. Stress. Stress can be emotional, biological, physical. But whatever it is, it will evoke an integrated response of we are integrating what? That's why it's called integrated. We are integrating the sympathoadrenomedullary system with the hypothalamic pituitary adrenal cortex axis. Yes, we have the sympathetic system, which causes release of catecholamine in the adrenal medulla. And we have this axis of hypothalamus, hypophysis, and adrenal cortex, where we shall be releasing the cortisol. So these two axes are integrated to call what we came to start about, the integrated response to stress. Stress is perceived by many areas of the brain, from cortex down to brain stem, including the limbic system and the reticular activating system. Yeah. So now, how are the axes activated? Look at this. Major stresses activated are corticotrophic releasing hormone and the ADH neuron, antidiuretic hormone neurons in the paraventricular nuclei, and adrenergic neurons of hypothalamus. Yes, major stresses, they activate those nuclei of the hypothalamus so that the neurons of ADH and those of CRH are activated. And activation of this axis occurs by the hypothalamic pituitary adrenal axis, cortex axis. We have corticotropin releasing hormone and ADH. These two hormones from the hypothalamus, on their release, yes, they stimulate STH release and ultimately elevates plasma cortisol levels. So when we have the two hormones released, adrenocorticotropic hormone release is stimulated. This elevates the plasma levels of cortisol. Cortisol will be produced by the zona fasciculata of the adrenal cortex. Okay. How is this axis activated? The sympathoadrenomedal system is a sudden exposure to any type of stress. Initially, this produces the sympathetic alarm reaction. The stimulation of adrenergic neurons of the hypothalamus ultimately leads to release of epinephrine from adrenomedulla and norepinephrine from sympathetic ganglia. So look at this. The sympathetic system, we have adrenergic neurons in the hypothalamus. When they are stimulated by exposure to any form of stress, it will lead to release of the catecholamines from medulla and norepinephrine, which is released at the sympathetic ganglia, yeah, within the sympathetic alarm reaction. So together, these hormones help in adaptation to stress by the following actions. So now we have catecholamines, we have cholesterol and cortisol. So look at this. One, they will increase production of glucose. Catecholamines will rapidly raise plasma glucose by activating glycogenolysis, and cortisol acts more slowly by providing amino acid substrate for gluconeogenesis. Together, they shift glucose utilization towards the central nervous system away from peripheral tissues. That's why we are having some hyperglycemia. And yeah, okay. Two, the free fatty acid supply is also affected. Epinephrine rapidly augments the supply of free fatty acids to the heart and to the muscles, and cortisol facilitates the lipolysis or lipolytic role. Yeah, the breakdown of the lipids in adipose. Okay. The third point, there are also cardiovascular adjustments due to these hormones. The catecholamines and cortisol raise blood pressure and cardiac output, and they improve the delivery of substrates to tissues that are critical to the immediate defense of the organism. So take this point, they improve the delivery of substrates to tissues that are critical to the immediate defense of the organism. Number 4, arousal. Defensively useful behavioral activation and focused attention result from adrenergic stimuli to the pertinent brain centers. Yeah, this is true. So there's arousal and focused attention, which result from the adrenergic stimuli to the pertinent brain centers. 5, there will be inhibition of activities that are not useful during stress and divert individuals and their resources from defensive responses to danger to stress. Yes, for example, CRH input to hypothalamic neurons inhibits growth hormone, gonadotrophin release, and sexual activity. So, when there is cortisol releasing hormone in hypothalamus, growth hormone release is affected, even gonadotropins and sexual activity will be affected. When you're in stress, that's why sex won't be so smooth, will be reduced. Sexual activity and desire, libido will be low. Okay? Interaction with immune system. Yeah. The hormones produced during the stress interact with the immune system to produce a balance between useful local cytokine production at threatened sites and potentially dangerous systemic effects of these immune system products. That is what happens. There's an interaction with the immune system, these very hormones. They interact with the immune system to produce just a balance between useful local cytokine production at threatened sites and potential dangerous systemic effects of these immune system products. Right. Okay, look at this now. I want us to look at this very critical. Within the hypothalamus, we have adrenergic neurons and neurons which will release the CRH and ADH, as we say. The ADH goes to posterior pituitary, and ADH neurons, yeah, they go to the posterior pituitary and cause release of ADH, which is antidiuretic hormone from the neurohypophysis. CRH will cause release of TSH and the also increase release of STH from the adrenal hypophysis. So the TSH will go to thyroid gland. When we have increased TSH, thyroid stimulating hormone, the thyroid gland is stimulated to release thyronines, which will go and increase the basal metabolic rate, T3, yes, or T4, thyroxine, yeah, to increase basal metabolic rate. So the cortisol released has effects. This cortisol, the very cortisol, can go back and inhibit the adrenal hypophysis. Yes, but we also said that this cortisol can go back and inhibit these very neurons in the hypothalamus. This is in the pituitary, now this is in the hypothalamus. This is the long loop inhibition. This is short loop. Okay, so now we can have, we said before that this CRH when it is input into the hypothalamus, feeding will reduce, growth will reduce, sexual activity will reduce, reproductive function will reduce, because these are not necessary during the stress. When you have stress, they are not too critical that you need them. You don't need sex at that moment. So we also say that the adrenal hypophysis we shall have reduced GnRH during stress. So the libido lowers, right? So that is cortisol. Then still the cortisol released. At this point, I want to talk about this and I come very here. When we have adrenergic neurons, these neurons through spinal cord and the like, they will go and branch to the sympathetic nerves, release acetylcholine at the preganglionic neurons. So this acetylcholine will cause release of norepinephrine at the postganglionic neurons of the sympathetic ganglia. Let's call it that. Sympathetic ganglia. We have release of norepinephrine. Yeah. Note that it is stimulated by acetylcholine, but the postganglionic neurons instead release norepinephrine. While here in the adrenal medulla, we shall release adrenaline or epinephrine. So now at this point, here we are. When we have norepinephrine, arousal is stimulated, behavior activation is stimulated, so is aggressiveness. This increase in magnitude. Now, epinephrine and cortisol have an effect of mobilizing energy and redistributing the energy towards the central nervous system. They also increase the responsivity of the cardiovascular system. Look at this. The cortisol also inhibits inflammation and immune response, as we said before, so that when you have, these are caused by local injury. So here to inhibit cytokines, when they decrease, they have an effect up there. So basically, that's the summary of integrated response. What you recall is what you write. Things are not hard. You just know the hormones, know epinephrine, cortisol. Those are the major three hormones. Their effects, they have negative feedback mechanisms. They inhibit some things like libido to lower it, and postganglionic, preganglionic. Basically that. Thanks for subscribing. Subscribe to David 7 Science Theater. You won't regret. You like our videos and you share to fellow students to also enjoy the videos we present to you. Okay, they are free of charge. You subscribe. Subscribe for more and better videos. Our platform is full of biology, full of science, full of everything you need. Okay.